remember that the sales comparison approach, which we covered before lunch, is only one of the 3 approaches or methods of valuing property. We said you would use a sales comparison approach, thank you, man. You would use a sales comparison approach most likely to value what kind of property? Residential or what? Vacant land. Residential or vacant land. Now we want to move on to the second of the 3 approaches to value. It's called the cost approach. The cost approach is an entirely different way of valuing property. It doesn't have anything to do with what a buyer might pay for it. Because the truth is, the kind of property that we're valuing with the cost approach, a buyer is never going to be paying for it anyway. We use the cost approach to come up with a value for properties that are not going to sell. Special use properties. So give me an example of a special use type property.
Church.
The church. What else? Fire. Did somebody say fire hydrant? How about a firehouse, maybe? Fire hydrant's an interesting one. A police department, a library, a university building, any type of public facility or any type of charitable type facility would generally be valued using the cost approach. And the reason we use the cost approach is there are no sales to compare it to. Remember, the sales comparison approach requires us to have other recently sold what? Comparable properties. Well, if I'm trying to come up with a value for a library, what are the odds of me finding a similar library that sold recently? There's just no point of comparison. So the sales comparison method doesn't work for these kinds of properties. I've had some people ask me in the past, well, why do you need to know what it's worth anyway? You're not going to sell it. So why do you need to know? You need to know for insurance purposes. Think about what's about to happen Thursday, Friday of this week. Could a church be damaged? Could the roof be blown off of a library? Do we need to have some idea of what that physical structure is worth so that we could have insurance on it in case that happens? Does that make sense for everybody? And so that's why we still need to be able to come up with a value for these types of structures, even if we're not going to sell them. And that's what we use the cost approach for. You need to know these 3 steps. There's 3 steps. This is the formula for calculating the cost value of a property. And it's a very straightforward formula. First and foremost, treat the land as if it's vacant. You're going to value the land separately. Now, you need to know that for real world purposes, but you also need to know on a test they're going to give you the land value separately. And the reason we look at the land as being separate is because we're going to deal with depreciation for the structure, but guess what land never does? Land doesn't depreciate. Does that make sense for everybody? So we want to value the land separately. That's step 1. Step 2, we're going to add the value of the structure as if it was brand new. We call that the replacement cost. What it would cost to do what? To replace it. If we were building that same structure brand new right now, what would it cost us to construct it again? That's called the replacement cost. And generally we're going to use a square foot method on that. We're just going to say structures of this type cost $80 a square foot to build, and you're going to multiply that times the number of square feet in the building. It's pretty simple. Okay? So value the land as if it is vacant, and then add what? The replacement cost. And then finally, the last step is going to be subtract the depreciation. But here's where you're going to mess up if you're not really careful. What do we say about land? It does not depreciate. So the depreciation is only going to be based on the structure itself. Does that make sense for everybody? The land doesn't depreciate. So what we're saying here is don't add these together and then do the depreciation. You want to figure the depreciation just on step 2 alone. Does that make sense for everybody? And then you're going to come back and do your addition and subtraction. So land value plus replacement cost minus any depreciation. Depreciation just means a loss in value. We depreciate properties because over time they become less what? Less valuable. they need more maintenance, they need replacement of things, they have less value over time. All right? When we talk about the cost approach, you could be on a test presented with the difference between something called replacement cost or reproduction cost. Here's what you need to know. It's very rare to use reproduction cost. Reproduction cost is very expensive. Reproducing something is different than replacing it. If you replace something, you get a very similar thing that serves the same purpose. What do you get if you reproduce something? You get an exact replica. You get the exact same thing. Now we're talking about structures here, folks. What kinds of structures do you think you would not want to have them replaced, you would want to have them reproduced?
Historical buildings.
Monuments, historic properties, things that are very old. If the courthouse in Pittsburgh burns down, which it did, and you're looking at the loss in value to Chatham County from that, is it just the cost of building a new courthouse with new features? Or is it much greater than that? It's much greater than that, because if you wanted to reproduce that thing, you'd have to do it with all kinds of expert craftsmen and materials that were dated from that time period. Which is going to be more expensive, replacement or reproduction? Reproduction, dramatically more expensive. So we generally don't use reproduction costs, we generally use replacement costs, except on historic structures. Historic structures generally would have a reproduction cost, which is why they're so much more expensive to buy what for? Insurance. Insurance is much more expensive on a historic structure because of this. All right? As I said, we're going to use the replacement cost, and we're usually going to use it as something called the square foot method. Square foot method is real easy. Properties of this type cost $80 a square foot to build, and the property is 4,000 square feet. What are you going to do with those two numbers? Multiply them, and there's your replacement cost. Simple as that. There are more accurate ways of determining the replacement cost, but you'll never have to deal with them on a test from a math perspective. You may have to know them. You don't have to know anything about them in detail, but you need to know that they are better than the square foot method. The square foot method is great because it's easy to work with. It's just not very accurate. Can you see where there would be a lot to be left desired if you're trying to figure out the replacement cost of a library? If you just said, oh, well, it's $60 a square foot times 25,000 square feet, would that probably give you a pretty rough around the edges estimate at best? Very rough. Because you don't know about the contents. You don't know about, you know, the different, does that include moldings, and does that include fancy brass fixtures? What does that include? You see what I'm saying? Are there more accurate ways? Yes, but what they involve is a lot more detail about what's actually in the structure. That's called either the quantity survey method or the unit in place method. You don't need to know anything about them other than they're much more detailed. So the cost, the square foot method simply says this dollar per square foot, this many square feet. What do you think the quantity survey or unit in place method is going to describe as far as cost of that property? Think, be more detailed.
The materials used.
The exact materials used. Not $65 a square foot. We want this many board feet of lumber. This many thousands of pounds of this size nail. This many feet of copper piping. This 27,352 man-hours of labor. Which is more likely to be accurate? Something like that or something that says $60 a square foot? Which one's going to be more accurate? The quantity survey, much more accurate. But God, think how tedious. Think how tedious to figure out. Generally speaking, there's only one entity that I know of that keeps their records in this way. The federal government does. The federal government uses the quantity survey method. If you wanted to rebuild the Pentagon, they could tell you exactly how many yards of concrete it would take. Because they know. They know already. Everybody okay on that? But mostly, and especially for all the exam math for you guys, you're going to use which method? The square foot method. You're going to use the square foot method. All right? Depreciation. Depreciation is a big idea, and it's an important idea. When you own property other than residential property, generally speaking, you're going to experience a loss in value of that property over time. Any loss in value over time is called depreciation. Now see, one of the things you got to train your brain about is to stop thinking of depreciation as a negative thing. Maybe it is. Maybe it's not. Anybody think of why depreciation may not be a bad thing? How many of you pay taxes? I hope all of you. If not, I need to take advice from you on what you're doing. When you pay your income taxes every year, you have a certain amount of income and then you calculate the taxes you owe based on that income, correct? Everybody with me on that? When you get to a point in your life where all of your income comes from investment property, so it's coming from what? If your income comes from investment property, where's the income coming from? Yeah, property owned, but what's the income? Rent. It's rent. Does that make sense for everybody? That's how you make money off of investment property. Turn your brains on.
Resell it.
That's not making money off of investment property. That's selling it. That's a whole different thing. If it's an investment property, how do I make money off of it? Rent. And that rent is income. There it is. She said, so I can offset it. Offset it's a wonderful thing when you start talking about income taxes, isn't it? See, here's what somebody never told you about people who make their money from owning real property. They don't pay taxes. They don't. And it's perfectly legal for them not to pay taxes. Because the IRS will allow you to depreciate the value of that asset. The theory is that that asset, that building, is losing value every year. Are you with me on that? Now, do we actually know that it's losing value? No, we don't. In fact, it may be what? It may be gaining value, but the IRS doesn't know and they take your word for it. So you can simply tell the IRS, well, gosh, yes, I did make $150,000 in rental income this year off of my investment properties, but just as luck would have it, darn it, those same properties depreciated by $150,000. I mean, you can understand my problem, right? I mean, I made $150,000 over here, but I what? But I lost it over here, so my income was actually what? Poor pitiful me, I made nothing last year. And if I made nothing, how much do I owe you in taxes? Nothing. Depreciation's not necessarily a bad thing, is it? And so, we're going to talk more about that, by the way, in chapter 18, but you need to get in your mind, you need to get in this idea that depreciation is a paperwork thing. It's not necessarily that the property has lost value, it's that on paper it has lost value. Now, can a property actually lose value? Yes. Of course it has, but for the most, it can. For the most part, though, we're talking about paper depreciation. We're talking about a loss in value that just happens in paperwork. Are you with me on that? Okay? And why would it be used? Primarily to do what? To offset what? Income. To offset income such that you don't show any income, and if you don't show income, you don't pay what? Taxes. Wouldn't that be nice? Okay? So, depreciation is any loss in value over time. You need to know the difference between physical deterioration, or what we call functional obsolescence, and economic obsolescence. That word obsolescence throws people for about 16 loops on the test. They freak out. You shouldn't know, Because y'all know what obsolete means. What does obsolete mean?
No longer.
Outdated. What else? Not useful. Irrelevant. Not desirable. We don't what? We don't want it. That's what obsolete means. So an obsolescence is any loss in value because of a loss of desirability. People don't want the property as much, so therefore it's worth what? Less money. Does that make sense? So, we need to know the difference between this functional obsolescence, and you didn't see this on the test, functional obsolescence and economic obsolescence. Functional obsolescence, you can see, you can touch, you can feel. Because functional obsolescence means there's something wrong with the property. 5-bedroom house with 1 bathroom. That is a functional obsolescence. Why? Because people would not what? They wouldn't want it. Would that lead to a severe reduction in the value of that property? 5-bedroom, 1 bath?
Yes.
Yes. An office building with no air conditioning. Is that a functional obsolescence?
Yes.
Absolutely. It's a functional obsolescence though because it's on the property. It can be what? Fixed. It can be changed. Does that make sense for everybody? It can be changed. An economic obsolescence cannot be changed because an economic obsolescence is not on the property. It's something wrong with the area. The airport is an economic obsolescence for Briar Creek. Why? Noise, traffic. A rock quarry would be an economic obsolescence nearby. Why? The blasting. If you've never been near one, the first time that happens, you think you're going somewhere you don't want to go. I'm telling you, that'll scare you to death. Being near a rock quarry when they start blasting, yeah. Oh yeah. There's one right over off of Durley Road. You go over on that part of town, off of like Glenwood and Millbrook, that area over there, and just wait around. And they blast on I think Tuesdays. It does feel like an earthquake. It does. And it's miles away and it still feels like an earthquake. That's an economic obsolescence. What else would be economic obsolescence? Give me some things you wouldn't want to need to be near. Railroad tracks. What else? Hog farm. Definitely an economic, especially if they're spraying it in the air like Smithfield Foods, right? Train tracks.
The sewage dump, or what is that over at like 64 and
The pumping
440?
station. You don't love the aromatic aroma that provides. So,
Every
you know.
morning I drive by there. And then they put up warning signs that they're like cleaning it, so be prepared for nasty smells. I'm like, it always smells nasty.
Yeah, it does. A paper mill would be an economic obsolescence, you know. And a paper mill can be an economic obsolescence for an entire city, right? Roanoke Rapids. Yeah. You mean you can smell South Carolina or you can smell the paper mill? I'm sorry. I thought she was going to say where she's from, South Carolina. When you cross over, I was going to finish it and say you go back in time 50 years. But I didn't do that either. So, oh, our little neighbors to the south. Bless their hearts. Paper. Oh. Yeah. Yes. Yeah. So it really wasn't the person riding in the car with you all that time. It was the paper mill you were riding on. Yes. It smells like rotten eggs. Very sulfury smell. The processing of it, the bleaching of it. It's the bleaching of the pulp that creates that smell. So a lot of sulfur compounds that get released. It's usually near a river. Most paper mills are near a river. Yeah. Why is that? Because they use water for cooling. most often. They use it to circulate the water through the plant for cooling because it generates a lot of heat.
Yeah, I've never heard of a paper mill.
Never heard of a paper mill? Yeah. There are lots of them. Go to Roanoke Rapids and stay around for a while. You'll smell it. You won't have to ask where it is. Just smell it.
See, I'm from Farmville, so.
I'm sorry?
I'm from Farmville.
Yeah, they don't have any in Farmville, but go north on 95. You'll find one. I don't even have to tell you. You'll smell it before you see it. Okay? Everybody good on the difference between a functional obsolescence and an economic one? So an economic one, we can't change. Why? It's not on our property. It's out of our control. Completely out of our control. And matter of fact, if you pay attention to the news, these lawsuits that have been happening against Smithfield Foods lately, those were because of economic obsolescences. How many of you paid attention to that? These landowners that were suing Smithfield Foods for the smell from the hog farms and the waste lagoons and the disposal. Did everybody see those lawsuits? Okay. Those lawsuits were based on the idea of an economic obsolescence. Because what they were suing, essentially saying was, you have so dramatically reduced the value of my property because of your activities on your property. Does that make sense? That's an economic obsolescence. Whereas a functional obsolescence, I can fix it because it's on my property. That doesn't mean I always will fix it. Are there going to be times when it's so expensive it doesn't make sense to fix it anyway? Sure. Sure. We would call that an incurable economic obsolescence, a functional obsolescence.
And it kind of goes back to the beginning, so wouldn't that be a part of the right of enjoyment?
It is. It is based on the idea of the right of quiet enjoyment, yes. That generally speaking, you can't, in your use of your property, you can't infringe upon the use of others' property. You can't limit what they do or somehow create hardships for them based on what you do on your own property.
How does that work if the pig farm is there first?
They don't really care who's there first. Generally speaking, the law does not take sides about who was there first. It's generally based on who's creating the nuisance. Who's creating the nuisance? Because the idea is, with nuisances, the idea is that you should buy a large enough property that your activities don't impact your neighbors. That you need enough of, you buy a large enough piece of property, it's not going to matter what you do because you're insulated. That's the idea. Well, that's a paper mill. Exactly. Exactly. Okay, we good on these? Depreciation as far as math questions go. And you're going to have to deal with this because remember, go back to those 3 steps of the cost approach. We back up back here. We said there's 3 steps to the cost approach. Step 1 was value the land as if it's what? Vacant. And then add the replacement cost. And then step 3 was subtract the what? Depreciation. So, depreciation is a math question. And when you get into the math of depreciation, you're going to have 2 really important numbers that you need to be familiar with. You're going to have something called the effective age and something called the economic lifespan. The effective age and the economic lifespan. Now, when we talk about the effective age of something, first, I guess I should talk about the economic lifespan. The economic lifespan is not how long we expect that the building will remain standing up. Because buildings actually outlive their usefulness from a standpoint of how long it'll be up. Does that make sense? If they didn't, we wouldn't see so many empty ones all the time. Generally speaking, when you see an empty commercial building, it has outlived its economic lifespan because its economic lifespan is the amount of time that we expect it to remain useful for its original what? Purpose. Is everybody with me on that definition? The amount of time we expect that it will remain useful for that purpose. Could it remain standing up for much longer than that? Yes. Sure. We don't care how long it's actually going to be standing. We care about its economic usefulness. So give me some examples of properties or structures that might have a shorter economic lifespan versus ones that could be around for many, many, many years longer. A convenience store, you think that's on the shorter end or longer end?
I would say, I mean, it varies. Like, it's like a little.
Well, then don't give me one that varies. So give me one that you think clearly
Like
shows.
family owned, you know, like it's not a chain, but like a family owned convenience store. I think that has a shorter lifespan than just, you know, one on sheets or something.
I would say you might want to flip that around.
Really?
I would say if it was going to be a chain-based version, it would have a much shorter economic lifespan than one that was family-owned. But I'll give you an example of a structure, and you tell me whether it's going to have a short economic lifespan or a long one. A church. Long. Very long. Most of the time you construct a church, how long do we expect that property to remain economically useful for its original purpose?
Till Jesus comes back.
There you go, you know. Long time. Long time. How long would you expect a Las Vegas casino hotel to remain economically viable?
Not long at all.
7 days? No, seriously, what, 15 years? 20 years tops? That's a terribly short economic lifespan. And that is, by the way, the city on the planet with the shortest economic lifespan is Las Vegas, Nevada. Because what did they do with them? Tear them down and do what? Build the same damn thing right back next place, right? You know, oh, what are you building over there? Casino. What was there before? Casino. All right, there you go. That's what they do. They have very short economic lifespans. So the economic lifespan is the amount of time that we expect it to remain economically useful, not standing. Like the hotel, I forget the name of it, the one that's on Capitol Boulevard, right down there by 440.
Yeah, hotel.
Crown Plaza or Capitol Plaza or something like that, you know.
That's empty.
Been empty for how many years? So almost 20 years, right? So is it still physically standing? Has it long since expired its economic lifespan? Absolutely. I think they are finally going to do something with it, right? Yeah. I think, yeah, they have been saying that for a long time. Okay? Is everybody good on the idea here? So the economic lifespan is how long we expect it to remain useful. Now, the harder one that people struggle with is the effective age. We're very vain as Americans. We don't care how old somebody is, we care how old you what? Look. That's the best way to think of effective age. We care how old the building looks and feels. Can that be different than its actual age? Yeah, because they could do what with the property? They could update, renovate. So here's what happens, folks, and this is why you got to say we don't care about how old the property is, we care about how old it looks and feels. I could have a building that's 30 years old that has an effective age of 5 years. If I do what with it? If I fix it up. Maintain it's not going to be enough to do that. But if I go through and I gut it, and I put new finishes. How many of you have been in a hotel that they've come through and you look at it and you're like, man, this place looks brand new. Well, guess what they just did with the effective age of that place? They just reset it. They just rolled it back. Now, they can't change the economic lifespan because that's going to always stay the same. But what they can do is roll the clock back. Does that make sense for everybody? And so, the way you do this as a math problem is just to write it as a fraction. And I know we don't like fractions, but I promise it's not that bad. You're going to put the economic lifespan on the bottom of your fraction. So if it has a 40-year economic lifespan, you're just going to write 40 on the bottom. What do you think you're going to put on the top? The effective age. So if it has an effective age of 10 years, it's 10 over 40. Does that make sense for everybody? 10 over 40. Do you have a calculator in front of you? Can you take 10 and divide it by 40? What does that come up to? It's 0.25, and that's a rate of depreciation. Whenever we're calculating a rate, what do we have to do? Times 100. So how much is our depreciation? 25 what? Percent. That property is 25% depreciated. Does that make sense for everybody? It is 25% depreciated. So I want you to. So the building has a replacement value of $125 per square foot and is 2,000 square feet. The building has an economic life of 50 years and an effective age of 15 years. So how am I going to write mine? What goes on the top? What goes on the bottom? What goes on the top?
Effective age.
The effective age is what? 15. What goes on the bottom? 50, the economic life. So it's 15 out of what? 50. Can you type that into a calculator? What is that? 30.30 times 100 equals 30%. Well, the property is worth $125 a square foot times 2,000 square feet. So if it was brand new, the replacement value would be how much? $250,000. Does everybody see that? If it was brand new. But it's not brand new. It's depreciated. How much is it depreciated? By what percentage? 30%. So we're going to multiply that $250,000 times 30%, and we get $75,000 in depreciation. Property is depreciated by $75,000. So could you go one step further and tell me what the structure is worth now? It was worth $250, it's lost 75, so now it's worth what? $175. Everybody following on that mindset? Now, the only way they can make this even the slightest bit tricky is if they tell you the actual age as well as the effective age. Do you care how old the building is?
No.
You care how old it what? Looks, which is its effective age. We do not care about. So if we said a 27-year-old building that has an effective age of 18 years, which number are you going to use? 18. 18. Make sure of that, and you'll be okay. So here's our formula again. When we're coming up with a cost valuation, value the what first? The land. And once we've come up with a land value, then we're going to add what? Replacement cost of the structure. And then finally subtract the what? Depreciation, but only depreciation of the structure. You need to make sure you have those 3 steps, because if you have those 3 steps, you absolutely can't get this math question wrong. The math is going to be super simple here, but if you forget the formula, it's not. So it's the land as if it's vacant, plus the replacement value, minus the depreciation of just the structure, not the land. The land doesn't depreciate. All right, so go over to your little packet. The one we were working on before lunch, the same one, the valuation packet. It's not like you have multiple. So neat. This is why I don't have children. What did I tell you? See, I could take I could take my dad's parental approach. My dad's parental approach, no, let him go do it. He'll figure it out. Meanwhile, I'm over there like putting my hand in like a saw blade, you know? Like, oh, you cut your finger out. You won't do that again, will you? My dad will watch you just mess yourself up. Like, he ain't gonna say nothing, you know? Watch it. Who's telling that? Watch it. You won't do that again, will you? But you know what? It's an effective method of parenting. He used to laugh at my mom because she said, stop doing that. Stop doing that. Dolores, he's going to do it anyway. Just let him do it. He's going to burn himself. Yes, he is. And he's going to do it again. Little fat hand get burned. I can hear him saying it right now. It's a wonder wonder I survived. It really is. I mean, this is also the man that would tell me to get down out of the back dash of the car. You know, I grew up in a time when you could, y'all remember riding in the back dash of the, y'all remember when cars had a dash big enough to get on in the back of the car, right? And I mean, this is the man that said, get down from up there. I didn't do it. You know what it is? He got me down from up there. So wonder I didn't get ejected. I mean, you know, like right out the windshield. You know, and here's the thing. He would duck to make sure not to injure himself. So if I went flying across the seat, you know, like, and he hit the front dashboard, I told you to get down. I wonder I survived.
You learn quickly though.
Very quickly. Yeah, exactly. It's like Darwin's Law. You learn or you don't survive. One of the two. And he very much took the approach of, listen, I'll make another one just like you. I don't care. You know, like, Number 14. How much depreciation has accumulated on a 40-year-old warehouse which was built with a replacement value of $750,000 if the building has an estimated economic life of 60 years and an effective age of 28 years? So when we're talking about depreciation, we're going to write down two numbers. On the bottom, we're going to put our economic life. So what is that? 60. And on the top, we're going to put our effective age. So we got what? 28. And if we punch that into the calculator, 28 divided by 60, we get 0.4667. And that's a rate, so times what? 100. So 46.67% depreciated. Well, from what number? What number depreciated by 46 or 47%? The $750,000 number. So, we take our value of our building, our replacement value of $750,000, and multiply it times 46.67%. $350,000. So that's our depreciation, is $350,000. Is that making sense for everybody? Okay? You take the effective age, divide it by the economic life, that gives you your depreciation percentage, and then you multiply that times the replacement value. Yes?
So I had it at 20, I mean, 0.4666, I didn't have to look up for the 6, 7, so mine came up to 349,500.
If you rounded.
Okay, do you have to round it?
No, you don't have to round. It's the same number. Don't worry about
I
it.
just don't want them to have that answer.
They will not do that to you. Rounding will never lead you to choose the wrong answer on the test. And so you gotta recognize that when you're dealing with really big numbers, any rounding can make a significant difference. So you don't have to worry about that. I didn't take it out, I just left it in the calculator, so that's kind of the unrounded answer right there. And it's actually 349,999.999999995. So, unrounded. All right, I want you guys to do number 15. Number 15 is a full cost approach question. First thing, I'm going to set you off on the right path. I'm going to write down the 3 steps for you. What is step 1?
Value the land.
Land value. And then plus, what's number 2?
Replacement cost.
Replacement cost. And then subtract, what's number 3?
Depreciation.
Depreciation of what?
Structure.
Of just the structure.
Why can't we just add the land value at the end? Just do the replacement costs and the depreciation and then add in the value?
You can do the land at the end if you want to, if you want to keep it more linear for yourself, yeah. What's interesting about that is you say you're always hot and she's always cold, and I'm looking, you're wearing a sweater and she's not. There might be some relationship between those two. 16. 16 as well, 15 acres. got it. See what looking for.
Complete guidance, Travis, complete guidance.
Well, there's only, how many steps? 3 steps, right?
I don't know if I did the right stuff though.
Well, let's look and see. Step 1, land value. What do they tell us about the land value in question number 1? Because the worship facility is being valued for the purpose of determining the cost of insuring the facility. The building is located on a lot that's valued at $96,000. So, what am I going to do with that?
Put it in the land value.
I'm going to put it down over here, $96,000.
Did that.
Contains 4,200 square feet of usable area. So what that 4,200 is going to go here with my replacement cost, right? So it's going to be 4,200 times something.
Times 110.
Times 110.
Yeah.
So what'd you come up with for replacement cost?
462,000.
$462,000. Everybody agree with that for replacement cost?
Yes.
So far, so good? You couldn't be that lost. 2/3 of the way there. So the only thing you're left with here is the depreciation. It tells us it is 15 years into an expected economic life of 50 years. So how are we going to write our little equation out here? 15 over what? 50.
I'm sorry. That confused me a little bit because it says 15 years into the expected economic life, and I thought it was effective age, and that's actual age, right? Because it says 15 years into
But
it.
they didn't give you any other things. So you have, I mean, we only give you one, you got to use that one.
Okay.
You'd only be looking for a differential if they gave you what? So what number did you use?
I stopped right there because I was confused. I didn't want to keep going until I had understanding.
Gotcha. So when they only give you one, that's the one you have to use.
Okay.
Did everybody understand her question?
Can you
She-
raise that?
I'm sorry?
Can you raise that up to, like, what you told us?
No.
Girlfriend, not you, the person.
Oh.
Or ask her to move.
That?
Thank you, yes.
Like that far?
No. This is my girl's here. Thank you.
Okay? So, we're 15 out of 50. 15 gone out of 50. The 15 is the effective age. Well, you know that the economic life is what? 50. They didn't give you another number, so the one they gave you had to be right. It's the age, 15 years into, so that's your effective age. So 15 out of 50, did you type that into your calculator?
Yes.
Okay, 15 divided by 50, what do we get? 30%? So 0.3, times 100, so that's 30%. Everybody okay with that?
I didn't do it.
You did not do it that way. What?
I just subtracted 15 years from the 50.
And what did that get you? 35 what? Okay, then how did that help you though? I'm sorry?
I guess that wasn't correct.
But so what'd you do with that number is what I'm saying though.
I took the 35 years and deducted the depreciation by 35. You're about to deduct by 30.
So you did 35%? Is that what you did? Okay, no. You can't just take the number of years and say that's the percent. You've got to do the math. You've got to say 15 divided by 50. It's not 50 minus 15, it's 15 divided by 50. Everybody okay? Yes.
So you subtract the economic life from the effective life, when you divide it.
Divide it.
30%.
Correct.
That brings us to 700. And you take that from the 96.
From the what? From the what? What doesn't depreciate? You can see, here's the thing, you can answer that question. What doesn't depreciate? What does depreciate? The structure. So what number are you going to use the 30% on? There you go, on the structure itself. So we want to depreciate only the structure. So what is 30% of $462,000? 138,600?
Yeah.
So minus 138,600. Now it's just a matter of doing the math, right? 96,000 plus 462,000 minus 138,600. What'd you do, Zena?
So that was the step I didn't do, that last step right there. So I stopped. I didn't know where to go.
Did you get to 30%?
I did. I got all that. I got the 138,600. I just didn't do the last step.
So you didn't actually subtract the depreciation. You figured out what the depreciation was, but you never subtracted it.
Exactly.
Okay, so land value plus replacement minus depreciation.
Okay, I got it. Thank you.
Okay?
So the total is 419,
419,400, I think.
Yeah.
Four 419,400. Okay, we okay on that one? All right, let's look at number 16. Same thing. So write down the formula. What's step 1? Land value. Step 2, replacement cost. And step 3 is what? Depreciation of just the structure. Okay, so what do they tell us about the land? The land has an estimated market value of $172,000. So we don't need to do anything else with that. They tell us that the building is 5,800 square feet at $90 a square foot. So can we calculate a replacement cost from there? 5,800 times 90. $522,000. Hopefully everybody got to that point, right?
Yes.
Okay, if you get to that point, then you get into the depreciation. So when we talk about the depreciation, it says the building was constructed 27 years ago. If the building is located on a parcel of land, blah, 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 value. The building has an economic lifespan of 40 years and an effective age of 17 years. Well, they've given us 3 different year measurements or numbers to deal with here. Which 2 do we need? 17 and what? 40. What is 17? That is the effective age. So 17 out of or over what? 40. 17 divided by 40 is 42.5%. It's 0.425 times 100. So that's 42.5%. And 42.5% of what number? Of 522. Just the structure. Everybody all right with that? Okay. So that's $221,850 in depreciation, and it's plus here and minus there, right? Land value plus replacement minus depreciation. Is everybody okay with that? $472, $150. Sound about right?
Where did you get that 221?
That's the depreciation. Did you calculate your depreciation percentage? That's 40 times 100. Percent
25%
of what?
5 to the 2.
Got it? Feel okay with that? 3 steps. And it will never be asked differently than that. There's no way they can ask it differently than that. There's no way they can complicate it. Okay? You will see that question. Yes, ma'am.
I got lost a bit. So I have the land value, when I did the depreciation, I was supposed to, after I got the amount, which is 4250.
4250 what? Okay, 42.5%.
Yes, and then I take that percentage from the $522,000, but I didn't remember.
$522,000 times 42.5%?
Let me see again.
Okay. You good now? Okay. All right, that's a cost approach. That's 2 down, by the way, for those of you keeping score. How many we left with? 1. That's not it. 1 more. 1 more. All right, so let's do this. Let's go ahead, let's take a quick break, and we will come back and we will do the last approach to value, which is the income approach, the income capitalization approach. All right, so take about 10 minutes or so, we'll come back and do the income approach. Why, you don't want me to start?